Alrighty, good morning everybody. Welcome back to another weekly live stream from Scalar Learning. And we are continuing the trend of solving SAT Khan Academy problems. Just making sure the live stream is working. Okay, we are good. We've got audio, we've got everything. I'm running a little late this morning, got to get to school, got to teach, so we're going to just jump right into it. And so sorry for last week. I know that I wasn't able to do the live stream. It was Thanksgiving and I was home with my family. So I really apologize for that. And we didn't get to do one, but we're going to do one today, and we're jumping right back into the mix, solving systems of linear equations. By the way, make sure if you haven't done so yet to subscribe. We got weekly videos coming out on the reg about SAT math. Also, we got cool other stuff happening too, math music videos, all sorts of good educational tidbits, so make sure to do that if you like what you see. All right, let's jump right into it. So we got a system of linear equations, non-calculator section, and we say for which value of k is there no solutions for PQ. As soon as you see something where it's like, hey, when is there no solutions? There's no solutions when these two lines are parallel. And that's what they're basically referring to. They make it more complex by having a p replace the, whether it's the x or the y, we don't know, but we can tell based on the arrangement over here. P is kind of like your x, q is like your y. So I'm going to go ahead and I'm going to simplify by isolating a q for both equations. Q is already isolated in the bottom one. And why am I doing this? Because this puts it into slope-intercept form. So I'm going to take that top one and start it up here, 6/5 p plus kq, equals 4/5. Let's go ahead and subtract 6/5 p from both sides. That goes away. We now have kq equals negative 6/5 p plus 4/5. They're really testing your conceptual understanding, because this isn't y equals mx plus b. Now it's q equals mp plus b, essentially, because this is your x, this is your y. And then last I'm going to divide both sides by k. That puts the k underneath on the bottom for both of these terms, because I'm dividing both of those terms by k. So let's go ahead and get rid of our k. And now we've got this finally all set up. So it says where there's no solutions. Okay, there's no solutions when the slope right here, these two values are the same, assuming the y-intercepts are different, which I'm just going to assume that they are for the time being. So we've got 3/5 has to equal, I think that's 6, right? So that is 6, negative 6/5k. And now we just have to solve for k. K has to make these guys equal. I'm going to multiply both sides by negative 5/6, right, to isolate the k. Oh, no, I'm sorry. I can't do that. I'm going to actually cross multiply, because the k is in the denominator, and that's a problem. So we're going to just cross multiply, and we got negative 15k over here. I'm going to keep the negative on this side, equals 30. 6 times 5 is 30. Divide by negative 15. Divide by negative 15. And we've got k equals negative 2. This should be correct. Uh-oh. Having the same slope. Oh, I didn't do it carefully enough. So no solutions. Wait, hold on. So I did need to think about the slope. All right, so before I look at the right answer, let's see if we can figure it out. So this gives us the same slope value, negative 2. For which value of k is there no solutions, no PQ solutions? So we got, if it's negative 2, because that gives, that does make it negative 4/5. So is there another way to solve this? Because do you have another k value that can even work? Let me think about that for a second. 15 and 3/5, but there's no k anywhere else. 4/5. What if it makes it 0? I'm kind of stumped. This would create infinitely many solutions. So there's no solution that I can think of. I'm kind of confused. Oh, darn it. None of the above. I didn't know that was an option. All right. Makes sense. That was a really hard one, because if you jump to that conclusion, you're like, oh, it's negative 2. You don't read through all the way. You can make the mistake that I just made. But good learning lesson. All right. Negative 11y equals this guy. Okay. For what value of c does this have infinitely many solutions? Now we are looking for the exact same line, same equation. So let's first go ahead and get it in the slope y-intercept. slope-intercept form, excuse me. So I'm going to jump into this by, let me write it down here, 11y equals 6 times z plus 1 minus 13y. And if you're new today and watching this for the first time, yes, I am always seeing these for the first time. So here and there, I can make mistakes. That's part of the fun. 2y equals, let's see, y and z have infinitely many solutions. It doesn't really matter which one's your x or your y, because we just need to get the exact same equation. And so 2y equals 6z plus 1. And then this one, let's go ahead and isolate that y as well. I'm going to just immediately move the 24 over. C times z minus 1 plus 24. Okay, how should we do this? Let's go ahead and divide everything by 2. And we've got y equals 3 times z plus 1. That's what that equation is. We need to get this to be the same. Let's divide everything by 4. Okay. And then we get y equals, and I'm going to even, so we'll say c over 4 times, you know what, I'm going to distribute both of these. It's going to be easier for me. That's going to go that way. So I'm going to say y equals, let's not do that. Y equals 3z plus 3. And then here I'm going to even, now that we got this 4, I'm still going to distribute like this. And I'm going to say c to over 4 times z minus c over 4 plus 6. The reason why I'm doing that is because now I have 2 data points that I can kind of use to figure this out. I know that c over 4 has to match up with that term. And I know that this whole phrase is the constant has to match up with the 3. I can do either or, set either or equal to each other, and I should get the right answer. So I'm going to set c over 4 equal to 3. I'm going to solve for c, multiply both sides by 4, and c equals 12. So 12 should be the right answer. It should give us equations that are both equivalent. And if I quickly do this in my head, I'm going to get, let's see, 12z. I'm just trying to make sure I didn't make any mistakes here. 12z minus 12 plus, and that's 12. And yeah, and you're dividing by 4 instead of 2. So this should be good. The 12. All right, good. Back on track. Okay, so then we got, consider the system of equations above. If x, y is a solution to the system, what is the value of the sum of x plus y? So x, y is the solution to the system. So we've got, let's see what we can do here. So it is the intersection point. Do we actually need to solve for this? Oh, I think I see what's going on. This is essentially going to, these are in point slope. And 1/3, so that's 1/3 and 1/6. 1/2 and 1/6. Now I'm trying to see if I can shortcut this instead of actually solving. And those both equal 0 at 1/3, 1/6, 1/2, 1/6. Okay. If I multiply, hold on, let me see if I can multiply everything by 2. What I'm basically trying to do right now is I'm trying to see if there's a way to make this easier on myself where I don't actually have to solve this thing, which I think would be way too long. There's got to be a shortcut. So y minus 1/6, x minus 1/6. All right, I'm just going to go for it and try and solve it the way that I can, just sort of a standard way. Is there anything else? Oh, wait a minute. So they both equal 0. I set them equal to each other. And then these guys are different. These guys are different. So they're both set to, but this is both where I think what I have to do, my first inclination, since they're both set to the same thing, to put them, to basically set these equations equal to each other and then solve that way. I don't know. All right, first of all, I'm going to get rid of the fraction. So this is going to be my approach. I'm going to multiply this guy by 2. So it's going to be 4 times x minus 1/3 minus 3 times y minus 1/6 equals 0. And then let's go ahead and solve this way. So I'm going to say 3y minus 1/6 equals 4 times x minus 1/3. So this guy, I'm basically adding this to this side, and then I'm flipping the arrangement. I'm dividing everything by 3. 4/3 times x minus 1/3. And this just goes to the 4/3 because this is essentially one gigantic, all of this is being divided by 3, but you can sort of like pull it out since it's one big multiplication chain. It's sort of like 4 times 2 times 4 divided by 2. You can basically just divide this and you'll get the right answer. It's not like everything is divided up. Okay. And then now we've got this in point slope. We got a slope of 4/3. Not sure that helps. Let me see if that does help. I think that we still need to find an intersection point. Okay, so I'm gonna do the same thing with this guy. I'm gonna multiply this by 3. So I'm gonna get 9y minus 1/2 plus 8 times x minus 1/6 equals 0. 9 times y minus 1/2 equals negative 8 times x minus 1/6. I'm just subtracting that from both sides. And then I'm going to divide everything by 9. So I'll say y minus 1/2 equals negative 8/9 times x minus 1/6. Okay. And so now we need to find our equation. I guess I'm just going to have to do a little substitution. Yikes, this is just a brutal problem. Like I said, I know there's a much faster way. That must be there, I just can't figure it out. Okay, and then we got, let's see, y equals, we can, oh, okay. Here, I'm just gonna actually do this. This is the best I can think of. Let me just cross this out so you're not looking at it. I'm just going to multiply this bottom equation by -1. So I'm going to make this negative, positive, positive. And then I'm going to combine it with my top equation. I'm just going to add them up. The y's cancel out. -1/6 plus, I'll just make this 3/6 equals 2/6 equals 4/3 times x minus 1/3 plus 8/9 times x minus 1/6. And then this is 1. You know what? I'm going to multiply everything by, we'll make this 1/3. Multiply everything by 9. So we got 3 equals 12 times x minus 1/3 plus 8 times x minus 1/6. And then we've got 3 equals 12x minus 4 plus 8x minus 8/6, which is 4/3. Okay, we're almost there. This is so bad. Okay, 7. I'm going to add the 4 over there. 7 equals 20x minus 4/3. I'm going to add 4/3 to this side and make this 21/3. So it becomes 25/3 equals 20x. And then I'm going to multiply both sides by 1/20. 1/20. So that gets rid of this. X equals, and let's reduce this to 5 and 4. X equals 5/12. So that's what x equals. And then let's plug it back into one of these equations up here. So it's 5/12. I'm going to just plug it into this one because it's the closest that I see. And we'll solve for our y value. So that's 8/9 times 5/12 minus 2/12, converting 1/6 to 2/12 equals negative y plus 1/2. All right. And then we get 3/12 times 8/9. Cross cancel. 1, 3, 2, 3. So that's 2/9. Negative y plus 1/2 equals 2/9. And then subtract 1/2, subtract 1/2. Okay, so that's 9/18. Sorry. Yeah, so it will be 4/18 minus 9/18 is negative 5/18. Negative y equals that, and then y equals 5/18. Oh my gosh, so what is the sum of 5/18 and 5/12? Is this really that hard? All right, so this is 10/36 plus 15/36, and this is 25/36. Let's see if that's right. That was insane. And I have never, on the practice test or on the real SAT, ever seen something so difficult. What did they do? They isolated 2x. So they distributed. And they isolated for x. They did it basically this way. They isolated for x. They set it equal to each other. Okay, to me, this seems like way too long and complex to ever actually include on an SAT test, but I don't know. I know that these problems sometimes can be harder than the real deal. That seemed a lot harder. All right, let's try this one. Consider the system of equations above where c is constant. For which value of c are there no solutions? Same thing, so this time we got to be careful and make sure that none of the above is again an answer. So we got to be really careful here. So again, A, B. A is my x, B is my y. And yeah, this is crazy. Okay, so let's go ahead and plus. I'm going to distribute that c right off the bat. Plus 0.8c. And then we're going to get 0.6 equals 1.5a plus 1.5cb plus, you could use a calculator apparently, but I don't think it's going to help much on this one. 8 times 184. 8 and 4 is 12. I think it's 0.12. Let me just make sure that's right. 15 is 120. So yeah, 8 would be 12. I'm sorry, 1.2, not 0.12. Just make sure. 40, 8, 12, and 2 decimals. Yeah, 1.2. Okay, cool. Gotta watch those decimals. All right, then we have 1.2c. And then now let's get it again. A, B. All right, so we gotta isolate B, right? So we need 1.5. I'm just gonna move everything else over. Pretend like this was on that side. 1.5 CB equals negative 1.5A minus 1.2C minus 0.6. So I did some of this in my head. I'm basically taking this, I'm subtracting this and this to get them onto that side. And then we have this. Last, I'm going to divide everything by C. I'm sorry, by 1.5C. And this is the key part right here. This is going to tell us our slope. The slope is essentially, because the 1.5's cancel out, it's negative 1 over c is the slope here. And we need the same slope there. And it looks like the y-intercept is negative 1.2 over 1.5 minus 0.6. Is that right? 0.6 over 1.5c. Okay. So now we've got it like this. That's the first equation. Like I said, I don't know. These are insanely difficult to me, but I don't know if it's fully accurate. Negative 2.5 times b minus 0.4 times 1.2 is 0.48 plus 0.6a. Keep distributing. 0.2 equals negative 2.5b. And we're trying to isolate b, right? Yeah. So this is b equals, all right. And then we got negative 2.5b plus, this one I need to calculate. 2.5 times 0.48. 2.5 times 0.48 equals 1.2. That's nice. Okay. Plus 1.2. And then that one is 12, 15. So I think it's minus 1.5a. Let's make sure. 2.5 times 0.6. 2.5 times 0.6 equals. Yeah, cool. And I got my minuses right. All right, I'm going to add 2.5. I'm going to swap these guys. So I'm going to add 2.5b, add 0.2 to both sides. So we got 2.5b equals negative 1.5a plus 1.4. I'm combining this with this. I'm just not going through all steps because this is going to take a really long time, and I do have to eventually get going to school. And then last, we've got to divide both sides by 2.5. 2.5. All right, so my slope here is 1.5 over 2.5 is, I think it's 3/5. So it's negative 3/5 is my slope here. So let's just first say negative 3/5 has to equal negative 1 over c. We're going to cross multiply again. Negative 5 equals negative 3c. c equals 5/3. But we have to make sure that this doesn't give us the same y-intercept. So if I plug 5/3 into here, oh my gosh, this is just so insane. Because I think it is an answer. So 5/3, so it's negative, so, okay. 5/3, so negative 1.2 over 1.5. 1.2 divided by 1.5 equals 0.8. So we got negative 0.8 minus 0.6 over 1.5. 0.6 divided by, was it 1.5? Yeah. 1.5 equals 0.4. So negative 0.8 minus 0.4. Oh, sorry, we can't do it like that. It's got to be 5 times. So 3/5. 0.4, and then it's like 5/3 on the bottom, so it's like timesing it by 0.6, so it's by we could say 0.24. So it's negative 1.04. I don't think they're equal. I just did that kind of quickly. I think that's right. I think 5/3 is right. Again, it's incorrect if these if the b values do match up from that constant. Let's see if that works. Yeah, it's right. Okay. All right. Oh my God, so brutal. I think these are crazy hard, more so than what you'll ever see from everything I've done. And I took the actual SAT a year ago and got a perfect score. So these seem crazy, but it is what it is. So again, consider a system where a is constant for which values of a is PQ 1, 1 a solution. All right, well, let's plug in 1, 1 for P and Q. A times 1 minus 1 equals 1. This is 0. 0 times A equals 1. This does not seem to make sense. And then for the bottom one, P equals 2Q minus 1. So this would be 1 equals 2 minus 1. So in the bottom one, it works. 1, 1 is definitely a solution. In the top one, 1, 1 will never be a solution, it looks like, unless you have 2.5. Hold on, let's see. Is there any way to make this work? Let me see if I can, if by any chance there's a way to manipulate it. AP minus AQ equals 1. And this becomes basically A minus A. It's impossible. I don't know. I think that's impossible because if it's 1, 1 up here, it's always going to be 0 equals 1. So I do not believe there's a way to do it. Yeah, that's right. Let's see the explanation. Because the equation, yeah, it becomes a false statement. See, they get that same exact thing. All right, well now, that was intense. I hope that was helpful for you guys. It was kind of interesting for me, but like I said, I do think those were uncharacteristically hard. If you have any questions, please leave the question in the comment. I'll make sure to get back to you ASAP. And like I mentioned in the beginning, please make sure to subscribe if you haven't done so yet. We've got great content coming at you every week. Just released a music video on long division. You should definitely check that out. And finally, check out scalarlearning.com as well. You can subscribe to our podcast, a weekly podcast that has great education information coming to you on the regular. Thank you guys so much for joining, and I'll see you guys next time. Have a great day.